Okay, so we've studied both proportional and non-proportional situations. We're going to combine them together and compare them. So the first one is linear and crosses the origin. Which one is that?
Proportional.
Proportional goes on your first blank.
Yeah.
It's a line and it goes through the ordered pair 0, 0, right? It's in the form y equals kx. Or you could say y equals mx, either one. It does not have a y-intercept. It does not have a b value. Okay? Does not cross the origin or is not linear.
Non-proportional.
That one is non-proportional. Okay? So that can be in y-intercept form where you have a b value, like y equals mx plus b. Or you could have another equation like y equals x squared, which is going to be a parabola. Those are things that are non-proportional relationships. We haven't done anything with parabolas yet. Okay, we're going to distinguish between proportional and non-proportional situations. So the first one is a graph. That first graph does not go at the origin, right? So we know that that one is not proportional. Only we already know because it does not start at 0, 0. So I could put does not cross origin. This starts at 0, 1, so we know it is not proportional. If we look at the other graph, that one crosses at the origin and it's a straight line, so we know that that one is proportional. And the reason we know it's proportional is because it's linear. It's a line, right? And crosses the origin. Oops. Crosses at the origin. So that's how you tell from a graph. First you have to see if it's a line. If it crosses the origin, it's proportional. If it does not cross the origin, it's not proportional. That's the graphs. Now the equations, remember, if it's proportional, it needs to be in the form y equals kx or y equals mx, right? So the first one is y equals x cubed. If this power of your x is greater than 1, it's going to be non-proportional, okay? Okay, and if it has an x squared or x cubed or something like that, it's also going to be nonlinear. It's going to be a parabola. So this is going to also be not linear. Okay, our next equation, we have q equals 4b. It's not the same variables, but is it in the same form? Yeah. So it's going to be what? It's proportional. Is it going to make a line?
Yeah.
Yeah, so it's also going to be linear.
Next one's non-proportional. Because that's mx plus b.
Yep, so that's going to be non-proportional. Let's put this one crosses at the origin, just so because I want you to just, you know that if it's linear and it's proportional, it goes to the origin. It's going to cross at 0, 0, right? I want you to tell me where this one crosses. It's non-proportional. Where does it cross at?
That's the negative 3.
Nope, the 7 is right, but what is the ordered pair that it crosses at?
0, 7.
0, 7. So let's say crosses at 0, 7. So now you can start looking at these equations and you're getting more information from them. You know exactly where those equations are going to cross your x and y axis if you fill in those values. Now we have y equals 1/2 x. It's proportional. And where does it cross at?
0, 0.
It's linear and it crosses the origin. It's going to cross at the origin. Does this make sense to all of you?
Yes.
Okay, and we still need to be able to recognize tables and see what kind of relationship we have. So we're looking for if it crosses at 0, 0 and if our rate of change is constant, right? Now it's hard to tell because this doesn't go 0, 0, but if we find our rate of change, we have 36 over 3, right?
12.
60 over 5.
12.
And 96 over 8, right? They all simplify to 12. So that tells me if I worked backwards, right? If this was 2, if x was 2, what would y be? 24. If x is 1, what would y be? If x is 0, what would y be? So that tells me that this is proportional, right? And it crosses at 0, 0, or the origin. It's also linear. I know all of that by looking at the table. The rate of change is constant, making it proportional, linear, and it crosses at 0, 0.
The next one is non-proportional.
Well, what's your rate of change?
Well, you got a 40 and a 50, and then you got a 60
They're
and
not
40.
constant.
So they're not constant. Good. So they're not equal. So I could just say it's not proportional, right? And I could say the rate of change is not constant. Rate of change is not constant. So now we can look at graphs, we can look at equations, and we can look at tables and understand linear, nonlinear, proportional, non-proportional, where it crosses our y-axis. Okay, let's go ahead and do our guided practice and we'll be done with our notes. Okay, page 117. It's to determine if each relationship is proportional or non-proportional situation. Explain your reasoning. So the first one, it's proportional because it's linear and it goes through. Oh.
Hold on.
I don't want to burn. I don't want to burn.
It's still recording. It's still recording.
I don't want to burn. I don't want to burn.
It's still recording.
You guys are gonna make me get louder. It's still recording. Let's go. Yeah. Am I recording? Yeah, it's recording. I can hear that.
Okay, so before the fire alarm, we already decided this was proportional. Okay?
Next one's non-proportional.
We gotta write this one down. Stop visiting, you guys. We need to write down that this one is proportional. And we have to explain. I'm gonna put line through the origin. Okay, the second one I already heard was non-linear, non-proportional. I mean, it's linear, sorry. Non-proportional. Because it doesn't go through the origin.
Linear means it's a straight line.
Is our rate of change constant on this one?
Yeah.
Because it's a straight. Wait.
No.
We would have 6, well, let's not use that one. We could go 6, 2, so 12 over 6, and then the next one would be 18 over 12. It's not. So if it's non-proportional, your rate of change is not constant. Rate of change, not constant. Okay, the next one says Q equals 2P plus 1/2. Why can I not move this? Guess they're hooked together now. Okay, so that would be non-proportional, and because we had a intercept, right? It doesn't go through the origin. So it's non-proportional. Oops, I'm gonna write non-proportional twice. And does not pass through origin. How about the next one?
That looks proportional because
It is proportional because it's going to go through 0, 0, right?
Yep.
Your intercept is 0. But it says to use this y equals mx plus b. When your b value is 0, it's proportional because it goes to the origin. Okay? When you use y equals mx plus b, if b is 0, you know that it's going to be proportional. If your x value is not to a power. Okay? On to number 5. The table represents linear relationships. Determine if each relationship is proportional or non-proportional situations. Now we're looking at a table. So if we simplify that, we'd have 12 over 3, right?
Yep.
36 over 9. What do these all simplify to? 4. So our rate of change is constant, right? Because we're finding y over x. It's proportional. Rate of change is constant. It's 4, right? The next table, we would have 4 over 22, 8 over 46, 10 over 58. Are those equivalent? No. So y over x, not constant. And then number 7, the values in the table represent the numbers of households that watched 3 TV shows and the ratings of the shows. The relationship is linear. Describe the relationship in other ways. So if it's linear, we know it's what? Does it go through the origin? Does 12... If we simplify these, 12 over 15 million and 16 over 20 million, what do they simplify to? No, it's going to be like a big decimal.
4/5. I think, isn't it?
12 divided by 15. I forgot my zeros here. 15 million. 1, 2, 3. 1, 2, 3.
Something 4/5.
I get 0.0000008, I think. 1, 2, 3, 4, 5, 6.
Error.
E means 10.
8 e negative 10. Or negative 10.
Yeah, 8 tenths, that's 4/5. Or 8 is 4/5. If it was a 10.
Do you guys not have the same calculator I have?
Mine just goes, mine says 8e negative 7.
E means
To the negative 7 power. Do you get that for all 3 of them?
We'll figure that out.
That's not the calculator.
Yeah.
So this is your rate of change. So you're going to have a rating, TV show rating for the number of households. So then we know it's proportional because it's constant. How do they ask 3 ways? And then we can say it would cross at 0, 0 too. Your rate of change is 0.0000008. It's proportional and it crosses at 0, 0. And then the last one, how are using graphs, equations, and tables similar when discussing between proportional and non-proportional relationships? What are we looking for in all of them?
Let's see if it crosses the origin or.
So we're looking for the y-intercept, right?
Yep.
That's whether it crosses the origin. What else are we looking for? Rate of change, which could be, because this could be 0, 0 or origin, right? Rate of change, we would notice as m or slope, right? And we can see that in graphs, equations, and tables.